In this video, we're going to be tying up some loose ends by talking about implicit versus explicit parameters. We're also going to talk about the reserved word this, which if you haven't seen the video on this dot notation, I recommend checking that out first. And then we're going to hit on instance versus local variables. This has actually been discussed in prior videos, but as I said, this video is kind of tying all this stuff together. I'm going to start off with this question. How many parameters does the following method call have? I imagine most people, at least most of my students, are going to say 2, but the answer is technically 3. Technically speaking, there are 2 different types of parameters. There are implicit parameters and there are explicit parameters. Explicit parameters refers to the arguments that are passed inside the parentheses of a method call. The things that we typically know as parameters are actually explicit parameters, technically speaking, right? These are explicit parameters. This replace method, is taking in 2 strings, x and y. The system.out.println line is actually taking in an explicit parameter, 3.14. Okay? As we've already seen, a method can define multiple explicit parameters, right? That replace method actually has x and y, more than one explicit parameter. The object that invokes or calls the method is also considered a parameter. It is an implicit parameter, right? In that exact same method call, str.replace x and y, well, there's actually a third parameter, str. And I want you to think about that for a moment. Parameters are basically inputs. In order to perform some type of function, some type of method, we need inputs. Right? Sometimes they take inputs, they produce outputs, sometimes. Right? This particular replace method is actually going to return a new string, but we're taking in 3 inputs. Right? Replace technically changes all the x's in str to y's in this particular case. Right? We're going to replace all the x's in str with y's. That's what the method does. Those are 3 different forms of input. We want to replace. Replace what? We want to replace x. With what? Y. In what? str. Okay? So those are the 3 inputs that are coming in order for it to perform its operation. And then they're all technically parameters. These guys that we know and love, that we're used to seeing as parameters, they are explicit parameters. Whereas this str, the object that is calling the method, calling or invoking the method, this is an implicit parameter, right? Length, right? It tells me how many characters are in the string. Well, this is effectively a form of input. This is a parameter. Length of what? Length of str. While a method or method call can have 0, 1, or multiple explicit parameters, right? Here we have 0 explicit. Here we have multiple explicit. Here we have 1 explicit. So a method can have 0, 1, or multiple explicit parameters. There can only be 1 implicit parameter. Right? It's easy to spot the implicit parameter in a method call. Here we created a new student, Daniel, and saved it into this variable, Daniel. Later on, I say Daniel.getName. Well, this is an implicit parameter. Right? Get name. Get name of what? Daniel. There's only 1 implicit parameter, and in this case, it's Daniel. It's easy to spot that in the method call. But keep in mind, there are kind of 2 separate sides to a method. We have the method call, which is where we actually tell it to execute, but you also have the method definition. How about in the method definition? Can you access the implicit parameter from the body of a method definition, or do implicit parameters only exist when calling a method? So whenever we define a method, we actually write down the names of our explicit parameters. Those exist in the method header. What about the implicit parameter? How do you refer to it? That's where the reserved word this comes in. We talked about this dot notation, and we saw the application of this dot notation, like why you want it. Here, this is more like the definition. This is why this actually exists. The reserved word this refers to the implicit parameter, the object that is calling the method from inside of the method definition. Before we continue talking about this, the reserved word, we need to get some more terminology under our belt. Instance variables have an access modifier and are one of the components that make up a class. Instance variables represent an object's state. A class declares the instance variables. Each instance of the class will have its own set of instance variables as defined by the class. Conversely, local variables do not have an access modifier. The variables that we have spent most of our coding career working with are local variables. They exist as parameters or variables defined within the method itself, right? Keep in mind we have spent most of our coding career working inside of the main method. So technically the variables we've been working with are local to the main method. Local variables do not have an access modifier. It's one easy way to spot local variables from instance variables. Here we go. We see public class rectangle, right? This is a class header, and we have our class body. We can clearly see our instance variables. They are in the class body. They have access modifiers. Over here, we're talking about local variables. Here's my class header. Here's a header for a constructor. I know it's a constructor, two different ways I can tell. No return type, and the name matches the class name. So this is a constructor, and we have two variables here, W and H. They are parameters, but they are local to this constructor. They only exist in this scope, right? They start existing here and they stop existing here. Area is a local variable in this case, right? It is in the body of the constructor. Note that none of these local variables have access modifiers, right? That's the big difference between these two types of variables. This can be used to refer to the object's instance variables throughout the class. Okay, so we see our constructor where we're taking in length and width. We learned that in our this.notation video that our local variables and our instance variables are effectively on two different lists, right? We can have local variables and instance variables with the same name. In this case, I have length and length. I have width and width. They technically exist in the same scope, right? These bad boys are limited to this constructor. These are limited to the class, but their scope will overlap into this constructor, meaning I effectively have two lengths. This dot notation is a way to distinguish between the two, right? This dot notation allows me to refer to the instance variable explicitly, right? This dot length means the length instance variable of this rectangle, the width instance variable of this rectangle. I'm saving this local variable into the instance variable. I'm saving this local variable into the instance variable. This dot length on the previous slide refers to this object's length, that is the length instance variable, while length refers to the parameter defined in the constructor header, which is a local variable. While using this is completely optional for this class, it arguably increases readability as we can declare parameters with more appropriate names. This will serve a similar function in mutator methods. Here we see we have name coming in, and I'm saving this local variable into our instance variable, and I can distinguish between the two. I can differentiate between the two, right? They're both called name. If I just put name here, right, name equals name, all I'm doing is saving the local variable back into itself. This dot is what allows me to refer to the instance variable. Okay, this is where I would normally kind of bring this stuff in, right? But I actually did a whole separate video where we implemented this. So I'm not going to do that right here. Instead, we're going to hit our recap. The object that invokes the method is known as a blank parameter. That's going to be an implicit parameter. Notice here it says object, the object that invokes the method, right? I don't want you to think, like the omission here is what's interesting. I could have said the variable that invokes the method, but that seems to imply that primitive data types could invoke a method, and they can't, right? Primitive data types, they don't have methods. Primitive data types can't call methods. What this means is that an implicit parameter will always be an object, always, right? Only objects can call methods. So the implicit parameter is always an object. A method/method call can only have one blank parameter. implicit is our answer here. A little bit later, we'll talk about static, spoiler alert. But a static method has 0 implicit parameters, right? Examples of static methods we've used before are all the things that are coming out of the math class, right? Math.pal, math.sqrt. What I want you to notice about those methods, and think back to when we've used them, we didn't make a math object. Let's go back. Here, I'm making a student object, and then I'm using that student object to call the method, right? This is an implicit parameter. It's an object. In the case of math, math.pal, I never make a math class. I never do this. I never make a math object, I should say. This never happens. Okay, how many explicit parameters does the following method have? Ooh, here we see a method signature. This method is defined in my class. It is called my method. It takes in 2 explicit parameters, right? Int x, string y, returns nothing. So we see 2 explicit parameters. That's our answer here. What I'd like you to note is it's not underlined to indicate so it's not static. This is a instance method. What it means is I will have to create a my class object in order to call my method. What this also means is in order to use my method, I will have 1 implicit parameter. That parameter's data type will be my class. Answer to our question, how many explicit parameters is 2? What is the implicit parameter in the following method call? Right, our implicit parameter is going to be here. It is my string. This reserved word is used to refer to the implicit parameter inside the body of a method. Our answer here is this. And that's going to do it for this one. I'll see you in the next one.